the one of the important concept related to development environments, that is collections framework. So as we are working with the data, so coming to Java, the data is nothing but object. Object is nothing but a data, collection of data we have, right? So whenever you are working with simple objects and all, it's fine. Working with one object, two objects is fine. But whenever you talk about a group of objects, right? So whenever you talk about group of objects, it is very complex working with them. So let's suppose I'm trying to access banking applications. So you know, like the data will be stored inside the database and all. So if I'm trying to access the banking, the details of all account holders, and I want to search the account holders based on different parameters. So I want to do some kind of sortings. I want to search, I want to do some sortings, I want to do some kind of orderings. So it is very complex operations when you come across working with, when you want to work with a group of objects, right? So like this, let's suppose Aadhaar card system is there in India. So how the unique number should be generated, and each unique number should be assigned to a particular person. Now if I want to search a particular person details through a number throughout this much population and all, it's very complex operations. So for this, we have some kind of programming in C and C++ and kind of programming languages. So we use some kind of programming, like we call them as data structures. So for arranging the data in a particular order, we have graphs, trees, and all. For searching, we have some techniques like bubble sort, insertion sort, quick sort, merge sort, and for adding, storing the data, we have some stacks, queues, lists, right? And we have different techniques. So searching the data, we have binary search, linear search, this technique, that technique. Different techniques are there. And these operations, whatever we are talking about, these are all very common operations whenever you whenever you have bunch of data. These are very common operations. It's not only related to programming. Whenever you have your data, where you store your data in your hard disk and all, if you arrange your data in a proper order, if you have a particular structure of arranging your data, then it is easy for you to what? Identify, search, or doing some operations on your data. It is also same thing here, right? So whenever you work with one, two objects, it's fine. But whenever you have bundle, group of objects, now how can I operate on the group of objects? If I want to manipulate, if I want to perform some kind of operations on groups of data, group of data, then how can I do this? It is very complex. And very commonly written, very commonly like this need, whatever the needs I'm talking, sorting, searching, arranging, these kind of things will be very common in every area, right? So as I told you, like if you have a bank database, if you have some our election voter ID card system, let's suppose everybody are enrolled into, you might have seen these things, everybody, whenever elections comes, right, people will be enrolling into the voter ID and all. Let's suppose there are duplicate IDs.
Yes.
There are duplicate voter cards are there. How can I eliminate them throughout this much of big population? How should I identify such kind of duplicates things? It is very complex. It is very complex, these things. Not only these things, like searching you can do, but performance, if I take the performance, how much time it takes. Lots of things to be taken care here when you want to perform operations on some group of data, complex. It is very complex. When your data increases more and more, the operations becomes what? Complex. So if I have 100 objects, whatever the technique I want to operate on the 100 objects, if it takes 1 second time for me, if I have 1000 objects to perform, let's suppose I have 100 objects, I'm collecting I'm collecting different data from different locations, data sources, and I want to arrange them in a particular order. Let's suppose if I have 100 objects, if I have to arrange these 100 objects in a particular order, if it takes one minute time, if I want to arrange 1000 objects, I should perform the same operations in less time. If I want to arrange lakhs of objects, I should be able to perform these operations on the same time, right? So these are the very common things we'll come across whenever you develop the applications, or whenever you do these things, searching, sorting, lots of things, whatever you do. Let's suppose if you go for a railway reservation system, now I'm going to do, let's suppose I'm giving my from to and all, it fetches the data from the database, it displays you need to book a ticket, and it should get from the available seats, and it should take the passenger details, lots of complex operations, right? So here, if I want to do this, generally we do these kind of things by using some kind of algorithms. There are some algorithms are there, some techniques are defined in industry standard techniques for better performance and all. So coming to Java, so what Java people has did is, instead of writing every time these logics, let's suppose I want to arrange the students in a particular order, at the same time I want to arrange my right machines in a particular order, starting order, right? I want to arrange strings. I want to arrange strings in a particular order. I want to arrange numbers in a particular order, like this. Instead of writing this technique for repeatedly for each and every time wherever you required, right? So Java people has given us a set of framework. Java people has given us a framework, right? So for doing these operations, so whatever the operations we do very performly commonly, so instead of programmer writing these logics for his or her application each and every time, so Java people has given some predefined predefined set of classes, right? So these classes, predefined set of classes and interfaces, we call as collection framework. This is called as collection framework. So what is the meaning of collection framework? So in other programming languages, people say data structures. So in Java also we can say Java data structures. But these data structures is already available for us. We are not going to write any of our own logic here. So we are going to take the help of already available ready-made algorithms. So the algorithm which you want, if you want to arrange your objects in a particular order, there is one algorithm is developed for you. So take the appropriate class which has that algorithm inside it and use that class for your objects arrangement. If you want to search, if you want to eliminate the duplicates, right? So like this, whatever the common logics to be performed whenever you are trying to work with group of objects, instead of programmer developing all these logics, Java provides you one framework that is called as collections framework. So it is a very common term nowadays which will be used, a framework, very common term in the industry, especially coming to Java, right? A framework. So you might have heard about Hibernate framework, you might have heard about Spring framework, you might have heard about JSF, right? It is also a framework, Struts framework, one of the famous. What are all these frameworks here? So all frameworks talks about a common code which should be repeatedly written in each and every application, and each and every framework targets different environments anyway. So this collection framework is kind of framework which is a ready-made set of classes and interfaces for providing you lots of common codes without writing your own code for doing whatever the operations I explained. So they have provided you with set of classes and interfaces, and all these classes and interfaces are bundled into one package. That package we call as Java Data Util. Util stands for utility package. So I can say Java Data Util package or collection framework or Java data structures all are same. But coming to Java, instead of writing your own code, if you go for C and C++ kind of programming language, people should write these things. So instead of writing them each and every area wherever you require, so Java people provided us a ready-made set of classes and interfaces for performing these kind of operations. And they have arranged in a particular hierarchical manner so that a programmer can easily use the ready-made available things, or as a programmer, if you want to write your own algorithms according to your requirement, absolutely you can do this by extending this framework, right? So this is what here, this is a very important framework, and every application will have this framework. Without this, we cannot imagine any Java application. It's the most important framework, right? So it's coming to this, very huge theory is there, but coming to usage of this, it is very simple to use, right? So this framework or util package is a set of classes and interfaces. This framework starts with a basic class called as, right? So this framework has two root interfaces, right? Whenever you talk about the framework, generally all the framework starts with some interfaces. So the first root interface is called as collection, and the one more root interface you have in this framework, that is map. So this framework is entirely deals with the objects, and that is group of objects. Whenever you have group of objects, and whenever you want to manipulate the group of objects, that means whenever you want to perform some operations on group of objects, instead of programmer writing his own logic for manipulating group of objects, so this framework provides us a set of classes and interfaces. And the two root classes in this framework are collection, and the other one is map. So what is this collection? We try to learn what is this collection and how to work with this collection. Later we see what is a map, right? So this is a collection. So what is a collection here? So technically speaking, collection is nothing but a object. Again, it is a simple Java object. Collection is a, spelling mistake is it, CTI. Collection is a Java object, right? So what is this collection is going to do here? Again, it is a object only. So this object contains what? Group of other objects. That is the meaning of collection here. So let's go through the API just once. So it is an interface. Again, simple inheritance is inside this. So the root interface in the collections hierarchy, that is collection, right? So very simple to work with. A collection represents a group of objects. Nothing is there. As I told you, up to now it's fine. Let's suppose I am defining a single student object. It's fine. Let's suppose if I want to define group of student objects, it's not always we'll be working with a unique simple data. We'll be working with groups of data, sets, right? So whenever you want to work with this group of data, how should I work with this? And as a programmer, I must be in a position to operate on this group of data very simple, without writing very complex logics and my own logics. So that is where this collections framework. So again, a collection represents a group of objects. Nothing is there. A collection is a Java object. I can say simple. It is an object and which represents what? Group of other objects. That's it. Group. So whenever you talk about groups, generally one more concept is there in Java that is already we discussed, that is arrays. Arrays also treated as what? Group of data only. But there is a huge differences are there in between this framework and that arrays. Actually, you should not compare these two things, right? But there are differences are there. So whenever you want to collect the data, right? Whenever you want to collect the objects, and whenever you want to perform the operations on this group, then instead of writing your own logics, you can take the help of this. So this is a root interface. You have collection interface, right? So there are different types of collections we have. So like this, you have set type of collections, list type of connections and all, right? So some collections you can see here. Some collections allow you duplicates elements, some collections will not allow you duplicates. Some are ordered, some are unordered. So I am not going to write anything here. Everything is ready-madely given for me. Just I need to know which type of collection I need to use, where I should use. That's it. If you don't want to have duplicates while you are collecting the objects, so while you collect the objects, if you don't want to see the duplicates, like rule numbers, right? Aadhaar card numbers, telephone numbers, you don't want to see the duplicates, then you go for some kind of collections which are given for us. Just you need to know as a programmer which type of collection I need to use in what case. That's it. So nothing as a program, because everything is ready-madely available for you. So you should not do anything here. So there are some properties. They may have some duplicates. Whenever you group the objects, they may contain duplicates. They may not contain the duplicates. They may be ordered. They may be unordered. If they are unordered, the latter you want to do ordering, yes, you can do. They may be sorted. They may not be sorted. Like this, you have different types of collections are possible for you, right? Right here. So the thing is, whenever you are trying to group the data together, whenever trying to collect the objects, that's fine, right? A collection is an object. But the thing is, if I don't know how much data, let's suppose I want to retrieve the data from my database. I want to retrieve the data from my database. Let's suppose bank. I want to retrieve the data from database. It's fine. You can retrieve the database from the database. If you don't know, how much data is there in the database, I want to retrieve the data from database, I want to store them into what? Some kind of Java objects. If I don't know how much data is there, right? So it is where that is the best. This is where this collection framework is the solution. So you need not to bother about the size of the memory, right? So whenever you are trying to collect the objects, right? So what is this collection framework is going to do? So it is, as I told you, it is a object, right? So this is a one Java object. To this you are trying to add the other objects, whatever you are, how many objects you want to add. So you are grouping all these objects into one bundle. You are making one bundle, and once all the objects are bundled into one area, then you can operate on this group of objects: searching, general operations, adding the objects, deleting, right, updating, searching, right, so retrieving. These are all the common operations, right? So adding the data to a file, right? So then let's suppose if I have a 1 GB hard disk, then you can save what? If you have 1 GB hard disk, you can add only 1 GB of data. Then after adding, you can delete, retrieve, whatever the operations you want to perform, you can do. But the beauty of this collections object is, what is this collection object? If you don't know the objects, how many objects you are going to add, if you keep on add the objects, yes, the size of this object will be automatically increases. If you add 10 objects, it allows you to add 10 objects. After this, if you want to increase like 100, 1000, lakh, like this, you can add n number of objects to how many objects you want to add. You can add all these objects to into one area, that is a collection object. Then once your data is added, you can perform all the operations: retrieving, searching, right, then deleting, updating. All these operations can be performed on this collection of data, right? Did you get what I'm trying to say here? So that is the meaning of a collection. It is not a new thing here. It is, I can say in simple, a Java object. A collection is a Java object which is used to store some other objects, Java objects. And once all the objects are stored inside this object, and you can easily perform the operations with the help of what? The ready-made set of methods are given for us. So you no need to write, let's suppose I'm adding person objects. As let's suppose I'm collecting the voter cards. Example I'm taking, I'm collecting the voter cards. Now I don't want to see the duplicates. I want to eliminate the duplicates out of all these voter cards. Now instead of writing your own logic to eliminate all these things, instead of writing your own logic to eliminating these duplicates, voter cards and all, so this framework provides you some set of methods. If you pass your collection object to that, if you pass your this voter card object to that collection, it is going to eliminate what? The duplicates. Right? Are you getting me? What I'm trying to explain here? Okay? So that is what here. Now whenever you are correcting the data from different locations, right? So when you are correcting the data from different in different ways, now I want to do some kind of ordering. Right? So like this, everywhere you come across, let's suppose if you take the examination system, and every student from different colleges applies for exams and all, then all the students data to be put into one area. For each and every student, they should allocate what? They should allocate what? The hall ticket numbers and all, where the students data should not be duplicate data. They should not get any duplicate data. They should eliminate the duplicate data. Lots of things has to be done. So according to that, instead of writing your own logic for eliminating such kind of things, right? So I want to search the student information according to what? If I enter a hall ticket number, it should fetch me all the information related to that student. Different things. Instead of writing your own search logic, instead of writing your own logic for eliminating duplicates, instead of writing your own logic for sorting the students, right? So this framework has provided you set of classes. Just take the help of that class, pass all the data to that object, and it is going to do whatever the operation you want to perform. That is what here. So this framework starts with a root interface called as collection, right? So this is the root interface. In simple, it is a object for collecting the different type of other objects, and it will be allowing you to have what? Duplicates, no duplicates. It does not guarantees. It does not guarantees at this level, top layer, because it is a top layer. At this top layer, it will not guarantee what type of objects you want to collect. But it is says what? If you see the methods here, add. So what is this add here? If you want to add a object to a collection, then you go for a method called as what? Add method. Right? So if you define the properties of a collection, these properties are like this. So whatever I'm talking about, this root interface collection. So what are its properties? Right? A collection is a first group of data. And what are its properties? If you define in simple, first of all, this is a Java object. The first important property of this is, right? So it is going to automatically increase its size. Automatically increase its size. And automatically decrease also. Increase and decrease. So this is the first property we have. So no bother about how much data you want to collect, right? And you can collect and you can group all this data into one object, right? So there is no problem with the sizes, right? Still, what you can, it is allows you to collect a homogeneous data, as well as it is going to allow you to perform a homogeneous or heterogeneous. You can have what? Heterogeneous data also. Homogeneous means what? Same type of data. Or heterogeneous means what? Different types of data. You can do this. Still, lots of things, right? So it can if you want to have if you want to have duplicates, yes, it is allows to have duplicates. If you don't want to have duplicates also, it is allows to have. So may or may not duplicates. May or may not have duplicates here as well. May or may not. So while you collect the objects, you will have different things. May or may not allow you, right, ordering. It cannot guarantee because this is a super root interface. It is more generalized form of collections. May or may not ordered, sorted. You cannot guarantee. If you want to have sorting, you can do it. But at the super most level, you cannot guarantee. May or may not sorted. May or may not indexed. Right? So may or may not, lots of things will be there here. Hello. Null values, because null is also one value which is for object. So like this we have different characteristics for a collection, right? So whenever you are trying to group the objects, so these are all the properties you may generally come across. Whenever you want to have, if you want to have duplicates, you can do this. If you don't want to have duplicates, you can do this. So this collection is divided into three different ways. So I can say about three different types of collections you have. So these three different types of collections are like this. List. The first one is what? List type of collection. So what is the meaning of list type of collection? It is one way of collecting the objects, I can say. Right. So while I am going to group the objects, it is going to perform some kind of specific operations. Right. So these are the three different types of collections you have. Right. So specialized forms of what? Collection. So it's simple inheritance you have. This is generalized form. So what we say, this is the most generalized thing. So these are all generalized things. And these are all what? Specialized forms of what? Collection. So they define what? Specific things. Now if you see the methods of collection, see here you have the methods like if you want to add. So as I told you, first you need to create the object, collection object. After creating the collection object, then you need to add the object to that. Add method is there, where by using which you can add the objects. Clear, remove entire data from your collection, right? Contains, searching. If you want to search a particular object, you can search it, see the object it is going to take. If you want to search a particular object, right? If you want to compare the objects, is this object is same as other object, right? Is empty to test whether you have the objects or not. Iterator, it is used to retrieve the data from the collection, right? Remove, for deleting the objects. See this, right? Again, this is array. It's a group of data. Whenever you talk about group of data, it is an array, right? But it has more features comparing to arrays. So if you want to perform the operations, adding, right, searching, retrieving, removing, all these operations you can perform without writing your own logics, because of there are predefined methods support is given for you. With the help of these predefined methods, you can do all these operations. That is the beauty of this collections framework. And this at super class level, at this super interface level, it defines only generalized, what all the properties of what is this generalized means. What is the meaning of this generalized means here? So all properties of what, whenever you try to group the objects. Now when you want to have specialized properties of this, then instead of going for this collection, you can implement you can have a specialized forms of this collection. So there is one specialized form is called as list. What is its specialized? Anyways, all collections will have these two common properties. What are these? They automatically increase and decrease and homogeneous and heterogeneous. The specific properties of list are allows duplicates. If you want to have duplicate data, absolutely you go for list, right? Allows, it is indexed, same like arrays. It maintains the data in the form of indexes, right? So if you want to perform the operations, you can go with what? Index based operations also supported. Now it is duplicates, indexed, ordered. The most important, it is ordered. So how we are going to collect the data? In the same order it is going to store the data, right? Allows null values, multiple null values, right? So like this, it is more specialized form of what? A collection. So that's it. That means if I use, as a programmer, if I use a list, type of collection, I am going to get my objects. All the objects can be added to a list with these properties. Duplicates, allows duplicates, indexed, ordered, and allows nulls also. Not sorted and all. When you want to have, let's suppose I am collecting my objects and I don't want to have those things, right? So if you don't want to have duplicate values, as I told you, I don't want to see duplicates. I just want to have unique, right? Then go for set. So it will filters the duplicates. So it will not allow adding any duplicate values to the collection. If it is added, it is going to ignore it. No duplicates, no order, right? It does not maintain the order. So you collect in one way, it is going to store in some other way. That is the meaning of no order, right? Then no, not indexed. It is not indexed. It's entirely different from what? One null value. Like this, it has its own features. Queue is the one which is introduced in 1.5 of Java. Instead of performing the operations on the group of object, these queues are used. It internally uses algorithm called as what? Queue. What is the algorithm which is used by queue? First in, first out algorithm, right? So instead of performing the operations on the group of data, this queue is used to store the data, right? So like this, so instead of, let's suppose if I am trying to group the data together, I'm trying to collect the data from different data sources, and I don't want to see the duplicate data. I want to eliminate the duplicate data. Instead of writing your own algorithm, this framework provides you that algorithm. Just you need to identify that algorithm, use that algorithm, then it is going to eliminate the duplicates for you, right? So such kind of things we call as what? Sets, right? So this is where again this list, set, and all. What are these here? So list, set, and queue are the child interfaces. Again, those are interfaces. Here you can see set, queue, and what? List. These are the interfaces. List is an interface, right? Ordered collection. It is going to sequence like array. Arrays are sequences, right? In the same way, if you want to use the data sequential manner, you can go with this list. But the difference is arrays are fixed in size, they cannot increase their size, they cannot decrease their, they cannot increase their size. Once it is defined, it is fixed. But coming to this list collection, they are automatically increases and decreases. Almost similar to what? Arrays. Almost similar. Now if you want to perform the operations on arrays, yes, you can perform, but all the operations should be performed on how the operation should be performed on arrays? By using indexes. Without indexes, you cannot perform the operations, but it is not like that. With some special methods. When you talk about the object orientation, if you want to perform the operations in object orientation, it should be with the help of what? Methods. And this kind of interfaces helps you to perform the operations with the help of what? Methods. Right? So list typically allows what? Duplicate values. It allows duplicate values. Right? So like this, same. It is also a child of collection. So it is also a collection. List is a collection. I can say what? List is a collection. What is the purpose of collection? Grouping the objects. Grouping the objects and performing the operations on what? Group of objects. That is the duty of what? That is how that is why this framework is given. So out of those, this is specific properties you have for a list, and these are the specific properties you have for a set, right? So here you have some methods here in the list, same adding the elements, and see here there are two methods. If you observe these two, so this method is from collection interface because a child contains the methods, all methods of the superclass can be inherited to a child. So this is the method from its super interface. See here, add is there, so you can add an element to a list without writing an index. In the same way, you can add a object to a list by using an index. So it gives you what? Index. Same like arrays. You can perform the operations with index or without index. Right? So like this, clear, deletes, contains for searching, equals, comparing, get, retrieves the element. Now if you have arrays, what you need to do? You need to remember the index position, then you need to manually write the code to get the element. But it is simply using the get method, you can pass it. Right? Check the indexes, iterator, retrieve all objects from your collection. Like this, you have some kind of methods here. And the second interface you have in this is set interface. A collection that contains no duplicates. A collection that contains what? No duplicates. That is called as what? Set. So while you collect the data, if you don't want to see any duplicate objects, instead of writing, as I told you, instead of writing your own algorithm to eliminating the duplicate data and all, use this. It is going to eliminate all duplicates things for you. That is the beauty of this collection framework, right? So like this, we have sets and lists. So these are specific things. Coming to this, lists and sets are specific things here you have. So like this, some set of interface are given for us. So what I do with the interfaces in Java? So all are whatever I am describing here, all are interfaces. Is it possible to work with interfaces? Right? So because all these are interfaces, you cannot create the objects for interfaces. You cannot create the objects for interfaces. If you are unable to create the objects, then there is no meaning of writing the programs. So if you want to do any kind of programming, you should have objects, then only with the objects only you can perform some operations, right? So before moving on to seeing this, what is the importance of these collections? So just remember this method. I am going to write this method. There is a method called as add method, which takes an object. See, it's only one simple example I am taking, add method. Just address the beauty of what? This interfaces. So now my question is, this add method is from where? Collection interface. This add method is there from what? Collection interface. Okay. So this is not, I am writing this method. This is already there for you in the collection interface. So this is from collection interface. So this add method is from what? Collection interface. Right? You can see there. And where is this? Add method. It is E means element actually. There is a different syntax is there for this. Now my question is, being a superclass method, is this method is available for each and every child class? Is this add method will be available in the list And in the same way, in the set as well as in the queue, is it available in these three different interfaces? Right? So this method will be definitely available in each and every area, because it is from what? It's superclass. Superclass methods are available by default to their childs. Right? Now we'll see here. So they are all given, these are all interfaces. Then what should I do here then? How should I use this add method? How should I call this add method? Is it possible for me? Right? So what they did is, Java people, they are also given for us the classes. Instead of these interfaces, so they have given us some implementation classes, implementations to this interfaces. So if you want to work with this collection framework, you can use those implemented classes for these interfaces. And remembering these properties is very important. Whatever I described, here some few of properties I have described here, remembering these properties is important. Right? So these are all interfaces, and very important interfaces you have. For each and every interface, there are some classes are given for us. Now we'll describe one by one these classes here. Again, I'm going to place my uh, classes in a architecture. Now let's suppose we start from a specialized collection. What is that specialized collections here? There are three specialized collections we have described here. One is list, set, and queue. Now we start from list kind of specialized collections. What is this list is properties? Again the same thing, list is a collection. What is the meaning of list is a collection? List is a object. List is a object where it can have what? Group of other objects. And if you want to perform the operations on this group of objects, and you can do this. Now what is the properties of this list object here? What is the properties of this list object here? The properties of this list object is, it allows the duplicate objects inside it. And how you collect the objects in the same order, it is going to do by giving each and every object index position, same like array. 0th index, first index, second index, like this. These are the properties of list. Allows you duplicates and orders the objects by giving the index positions. Right? So this is what this is what the list properties, and allows you multiple null values and all. Now, but this interface is implemented in different classes here. So this interface is implemented for us in different ways, right? So try to understand these different classes, whatever you have here. The first and most important class which is used very commonly is array list. What is this? Array list. And the second implementation for the same list, linked list. Right? So you have some other two classes here. Vector is the one more, and the other one is stack. Right? So this is the interface, and what are these things here? Whatever I drawn here is their classes, and these classes are already implemented for you. As a programmer, you are not going to implement this interface. If you want to implement this interface, absolutely you are free to implement it. Nobody can stop you. You can write your own class from this, and you can write your own logic. Generally, whatever the classes you write, list implementation classes, so whatever the behaviors we described, so those classes, each and every class will have those behaviors, right? So vector, array list, stack is a child class for what? Vector. There is a meaning of this. Stack is a child class for vector here, right? So in between this, there are some. In between this, there are some other classes are there. I think this is a class again, but this is abstract class. All object orientation rules here. Abstract list. These abstract classes are not important for you, and like this. So here you have one more abstract class inside this. abstract sequential list here. This is also abstract class. So what is the meaning of this? So as a programmer, you don't need to do anything. All are available for you. Just you need to make use of these things. And as a programmer, you need to decide where I should use what class, where I should use what class here. So this is the architecture of classes you have, right? Just I am giving the architecture of classes here. Array list is directly from abstract list. Again, vector is also from abstract list, but linked list is from abstract sequential list. Now my question is, this is from this. Now my question is very simple now. As I already told you, right? So previously I have asked you to I asked you one question. This list is from what? This list is from collection. So in this hierarchy, if you divide this hierarchy into different layers, so what are all these things? These are all classes. This is an interface, and these are abstract classes. And as a programmer, whenever you want to work with group of objects, means what? Working with group of objects means what? You need to collect all the objects into one area, then you can manipulate the objects for searching or any operations, whatever you want to perform on your group of objects. You can perform very easily. So if you want to group the objects, there are few classes are given for us. And all these classes, what are all these classes here? So these are the 4 different classes which are given for us, which are implementations of type what? List. So what is the meaning of implementations of type list here? What is the meaning of implementations of type list? So all these classes has these behaviors. Whatever the behaviors we have discussed with the list, right? All these will be there inside this. So what is this? First, all allows you what? Duplicates. This is the first important one. All allows you duplicates. All will be what? Ordered, indexed. Yes, every class here is indexed. Every class here is ordered. Right? Every class allows you null values. Then why these many classes are required? Why these many classes are given for us for doing the same task? So all classes are used to collect a group of objects. All classes are used for collecting the group of objects. Each and every class, whatever you see, all are used to collect the group of objects. Why these many classes are given? And each and every class definitely will have these properties. Array list is a collection, list, linked list is a collection, vector is a collection, stack is a collection. And all these 4 classes will do this kind of arrangement of your objects, will do this kind of storage of your objects. Then what is this? Why these 4 classes are required? Now my question, right? So now as we discussed previously, there is one method I have shown you previously. What is it? Add method, which takes what? An object. Now it is from what? It is from where? This add method is from a collection interface. Yes, this add method is from where? Collection interface. Yes or no? Right? Now my question is, so this add method is there inside what? List also. That is what we have. This is a method actually. This add method is there inside list. Now can you say, is this add method will be there in each and every class? Whatever the classes have written here in this diagram, is this add method will be there in each and every class or not? This add method, whatever I described here, so this add method will be there in each and every class. Array list, yes, this add method is there. Not only add method, whatever the methods we have seen in the collection interface, all these methods will be present in each and every class. Add method, remove method, clear method, contains method, iterator method, each and every method will be there inside what? These child classes. Simple inheritance inside this. So that means what? This add method, what I am trying to explain, what I am trying to explain here. So this add method, as you are saying, this add method will be there in each and every class in this layer architecture. So array list will have add method, linked list will have add method, vector will have add method, stack also will have what? Add method. And each and every class will have its own version of what? Add method. So what is the meaning of that? We try to see, understand. Just I am taking the only one example of one method. Each and every class will have all methods from its super interfaces. Right? So what is this array list here? In simple I can say array list is a list and array list is a collection, because list is a collection. Array list is a list as well as it is a collection. And array list object will have what? Array list object can do these kind of property, will contain what? These kind of properties. Now how should I utilize this? Right? Very simple to remember here. Each and every collection, whatever the collection I described previously, whatever the collection interface I described, and the classes, each and every class here is said as what? Collection class only. Whatever I see these classes, implementations, each and every class is called as a collection. Every collection class has, so these classes, whatever the classes you see in the bottom layer, array list, linked list, or any other classes you can take from the collection. There's a big API you have. Every class will have a no argument constructor compulsory. Every collection will have a no argument constructor. That means what? Now how can I create object for this? How can I create object for array list? These are all implementations, classes only. How we have written our own our classes till now. So these are all some available, ready-madely available classes for us. Right? So how can I create a object for array list? Array list, some reference is equal to new array list, new no argument constructor. How can I create object for linked list? Linked list L is equal to some reference is equal to new linked list. And my question is, can I call on that object? Can I call this add method? On array list object, can I call this add method? On a linked list object, can I call add method? On a vector object, can I call add method? Absolutely can call the add method on all these objects. So this constructor will be there in each and every class, no argument constructor. As a programmer, you can use this constructor to create the object for these classes. And the second thing is, right, one more constructor will be there, a constructor with argument, a constructor with a collection argument, which takes a what? A collection object as argument. These two will be there inside what? Collection object as argument. So collection object as argument means what? What is the meaning of collection object? A collection is again a group of objects, right? So as we are discussing, a collection is a group of objects. Whenever you talk about a collection can have what? Some other small collections inside this. A collection can have what? Small collections inside this. So this is one collection, and I can have what? One more collection of my objects like this. And all these collections can be added into one more. And I can perform on the operations on what? These kind of different collections also. So these two constructors will be there inside what? Each and every class of collection. Constructor with no argument, constructor with what? Constructor with no argument, and constructor with what? Collection object inside it. So these two will be there, right? So we'll see here. So we are talking about list here. So list is an interface, is collection, this is list is an interface, and it has its own implementation. So these are the specific things. List is nothing but a sequential order. If you want to arrange your data, now you are collecting the data from different locations, and you want to arrange them in the same order how you are collecting, right? So in that case, you go for what? This kind of object, which is going to store the data, whatever the data you are collecting, in the same order how you are collecting, so that as a user you will have a good control over the data, because you know what data is there in which area, because you are collecting and you know the order of this data, and you will have precise control over what? The data which you have added to this collection, and all the data will be stored as indexes. right? So these are the implementations you have here, right? Abstract list, array list. This is the one implemented class and very hugely used in the development environments. Vector, stack, linker list. All are collections only. All are lists. Now what is this array list is going to do for you? Array list is from abstract list and abstract collection. This is what the diagram shows you. Alright. So what is this algorithm internally? See, as I told you, there are algorithms are written for you, and each and every class will have a algorithm internally implemented. Each and every class is implemented with a by default algorithm. So as a programmer, you no need to write anything. Resizable array. What does it mean? What is the meaning of resizable array? As a programmer, if I write my own array, if I create my own array, that means what happens there to that array? The size of that array will be fixed. It cannot be incremented in the future. Now let's suppose, so this is also array. Array list is nothing but an array only. But what is the difference between array and array list here? Let's suppose if I create my own array, right? Now before creating the array itself, we should know always how much data I am going to add into that array. If you don't know the size of data, then you cannot create the array. Without bothering of the data, how much data you are going to collect, right? And if you want to add all this data, if you want to group all this data, then go for what? Array list. It is internally resizable array. So this array, whatever the array which is given for me in this framework, this is resizable. Automatically it is going to increase its size. You take the data, how much data you want to take from outside, you take all the data and you keep on add the data to what? This object. And it is going to keep on increase its size, right? And it is going to order your data in the same order. And if you want to perform the operations by using what indexes, yes, it allows you to do all these operations, right? So this is resizable array. It internally uses algorithm called as resizable array. Implementation of what? List. Implements all optional list operations, permits all elements, nulls and all, right? Interface, this class provides methods manipulating size of array and all. It is an array only. It is not a different thing. It is an array. Almost it is an array, but the difference is this automatically it is going to increase its size, right? Now how to create this? Yes, absolutely, as we discussed, you can create each and every class will be provided with what? As I told you, a no argument constructor and a constructor which takes one more collection object. It's very simple, straightforward to create this, right? Now how can I create the object for this array list? In simple, so right, so my program name is array list demo. It's fine. Right, public class. So what is my intention? So here I want to work with a group of data. That means group always we call as collection, right? And so there are ready-made set of classes are given, so I don't bother about collecting the data and bundling them into one piece and then operating on the data. No worries. Yeah, I can simply use this framework which is going to take care about all these operations, right? So that is the importance of this framework here. Now what is the class I would like to use? Array list. So it is array only. Array list is nothing but an array only, but it is automatically increased. New array list. Very simple. How I am creating the object for my own classes? The same way I am creating. This is a predefined class, right? This is what we have here. Now how to add the elements to this? No problem. Very simple. There is a method is given, add method, which is going to take what data I want to take, but all these are what? Objects. Whatever the data I want to add it. String object, right? If you want to add a student object, right, create it. Whatever the object you want to create it, student. I think there is a class with student, s is equals to new student. right? Now add this student to this array list. How should I add it? That's it, very simple. Huh? Yes, I think we have account object, create it and add it. Account A is equals to what? New account. So what I'm trying to do here, I'm just trying to group the objects. It is not general case where you don't find such kind of a requirement of collecting heterogeneous things. Generally, whenever we group the things, most of the times we'll be grouping what? The same type of data together. And it works with only objects. Remember, it will not work with primitive data. It is always works with what? Objects. So al dot add of what? 1. Right, just let me compile this program. So what I'm doing here, I'm having different objects. I'm taking from just object is a data. I'm taking the different data from different sources, and I'm adding all these data to what? One area. And this is a collection. This is the object I'm talking about. This object we call as what? Collection object, where I can store all objects inside this, right? So let me compile my program here. cd online classes clear CLS Java C array list demo. It's taking too much of time. Yes, each and every object is created, fine. And Java, nothing actually I'm printing here. Saying what? Exception thread main java.lang. No such method error. Person. Where is the person? Did I add person to this? No, right? Okay. Because of this student, it is giving me the error. And because student extends person, I think. In my program, whatever the class I have written in this student class, it extends from person. There's a reason why it is giving me that error. Let me remove that inheritance. Yeah, absolutely. Now it's fine. Oh. Lots of code I need to modify. It's fine now. No need to modify. Any modifications are required now. Still. Instead of doing this, it's better to have here itself. And just oh. It's fine. It's fine now. See there? See, you can see here how my data is there. This is string object, yes. This is student object, account object, and this is simple integer. It's not integer actually, integer object. So I am able to collect what? Different types of data together. And if you want to perform the operations, easily you can perform deletion, searching, iterating means what? Retrieving, and all operations you can perform on this. Generally, we don't come across such kind of scenarios wherever most of the cases will be performing the operations on same type of data, right? Right. So what it does here, what is this array list is going to do here? Now you put your all data into what? One area now, and it is very easy. Instead of writing your own logic, right? It is already given a class for you, and with the help of this class, you are able to put all your objects in one area. And if you want to perform operations on this, you can absolutely do this. I don't want to see a student object. I want to remove it, right? So because it is indexed, now if you want to get the data, get the object, get by using fourth. the data which is there inside a third index. I want to get it. Yes, absolutely you can get it without writing your own, with the help of this simple method. Right, it is going to get the object from that particular position, third index. I think it gives you one. Yeah, see, it is retrieved you. You can check a particular object is there or not. System.out.println, right, contains, just searching, just I want to see whether it is having in my collection, whether I have a object with the data. Let's suppose hello. Is there any object with hello? If it is there, it returns you true, otherwise it is false. Now if you want to do this operation, let's suppose this operation I'm talking about, if you want to do this operation, so as a programmer what you need to do here, so let's suppose there are 100 objects. Now I want to search a particular object from that. So you start searching that object from the first object. Search whether this object, whether this position is having this hello or not. No. Then go to second, then go to third, then go to fourth. You need to write a big algorithm, logic for this searching. It is very simple. You don't need to do this. Simple search it. Pass the data, add the data, group the data into one location, AL, and search, retrieve, add. See here how simple these things are. So what is this actually array list is going to do for you? What is array list here? Again, it is a simple resizable array as we discussed. Array list is what here? Array list is an resizable array. Automatically it is going to increase and decrease, and as you see here in my program, absolutely it is going to allow you to what? Allow you to have what? Heterogeneous data, but it is not possible with arrays. If you define an array, it is fixed. You cannot increase, you cannot decrease. Let's suppose I want to retrieve, you need to know the index position. If I want to search, you need to write your own logic to searching, right? And it will not allow you heterogeneous data. It is one more drawback you have, and it cannot increase. See here, how much data you want to add, you can add. Still I'm copying 4 again. I'm going to add them. Again I'm copying 8. I don't know the size actually. I'm adding this. So there are totally 16 elements, and I have some duplicates inside it, right? Repeated data inside this. Now just let me compile this program, and you can see there you have 16 objects bundled, and it is allowing you duplicate data. See there, you can see the duplicate data, and it is doing the same operations. It is searching, it is retrieving. Very simple. And without knowing the size, that is a very important. I don't know how much data I'm going to collect, and I don't bother. I'm just keep on collect the data and add into one object, and I'm able to do this. And after this, you can do your operations, right? So it is resizable array. It is not doing anything here. So it is what it is doing here. It is going to create you an object here. It is going to create you an object initially. So initially, it is going to create your object with indexes, same as array. How the array is going to create you the object, the locations by using indexes starts with 0, 1, 2 like this. Right? So initially when it is created like this, it will have 16 positions to store 16 objects. So exactly how many objects I have in my array list now? I have 16. So initially when you create it, it will have 16. It will be creating for you with 16 positions. See there, this is the constructor I have used, and okay, it's not 16, it is 10 only. Constructs an empty list with an initial capacity 10. Initially its capacity is 10 to store, so this capacity is able to store 10 objects only. But how many objects I have added? 16. Then what it does is automatically increased its size. Right? So adding the data is very simple. Very simple adding the data. say this. Right, so how the data is added here? I did not specify it here where to add this data, because array list is a collection. I did not specify where to add this data, right? So it keep on adding in the first position. First object will be added into what? First position. Then the next object will be added into what? Next position, like first index, like this. We don't specify any index. It is always adds the data to the end of the existing collection. Or you can insert the data, or you can insert the data to collection, or you can insert the data by indexes also. See, add appends the data to the end of the list, or if that's your choice. If you want to add the data in the middle also, you can add it. Getting me what I'm trying to explain here? So there are 10 positions only initially when it is created, but I have 16 elements in this. What it is doing here for me, it is automatically increasing its size. I don't bother. Absolutely, I don't bother how much data I'm going to collect, keep on collect it, add it to one area, and afterwards you do your operations on this group of data. But because it is a list, whatever the list properties we discussed, it will have all these properties. So it is internally an array only. I can say it is internally an array, but it is resizable array, and it is very simple to work with this array. Instead of writing your own array for writing your own logics for searching, sortings, this and all, very complex, very complex. It's very simple way to do this operation. See here. Now if I have hello, if I want to search it, again it is going to do the same thing. Right? So this is what here, array list. Add index position adding is there. Right? If you want to add one more collection to this, you can add. If you want to remove all the elements, you can do. If you want to search, you can do. Right? If you want to increase the capacity, right? How much it is going to increase? I'm saying that it is going to increase its capacity. How much it is going to increase its capacity? Right? So generally it is going to increase the current capacity. Whatever the current capacity is there, to that current capacity is going to increase by 3 by 2 plus 1. It is going to add still 3 by 2 plus 1 positions to the existing capacity. Now when 11th element I have added, so it is updated its size to what? 3 by 2 plus 1. So like this. It is going to, each time it is going to increase its capacity like this. So like this you have this. You can search the element, you can get the element by using get is empty to test whether the data is there or not. Iterator to get all data, whatever you have added, all data you want to get, you can use iterator. Get means only one takes the index position and retrieves the data. If you want to get entire data from your collection, you can go with what? Iterator. Right? List iterator is also same. If you want to delete, yes, you can delete. If you want to remove the data from a particular range, position to position, you can do this. If you want to replace the data, you can do this. If you want to get part of data, partial data, you can do this. Instead of writing your own logic here, just pass the indexes, get the data. Right? So like this you have here, remove the data from range, just pass the indexes and remove, ask it to remove it. It removes the data. See, all operations, whatever the common operations you will perform, all are available for you. So this is what array list. So it is internally what? An array. And very simple. Now my question is, this is one question. Can I change this name to a linked list? Is my program works or not? If I change this name to a linked list, is my program works or not? It works compulsory. Why? Because these two are from what? The same collection list. Add method is there inside array list. Again, the same add method will be there inside what? Linked list also. There is a beauty of this architecture. That is the reason I am asking. Add method is not from array list. This method is from what? List. Array list will have that add method in the same way. Linked list also will have the add method. Getting me? It will, definitely it will work. That is the beauty of this framework. Just I changed my class name, then what is the difference you see? If I change the class name, what it is going to do? What class name I have taken here now? I have taken, instead of array list, I have taken linked list. Then what is the difference you have? Both are same? Are these both are same now? What is the difference you have? If you change the class name, what it is going to do for you? Right? There's a big difference is there. A simple class name change, it's fine, but there is a big difference. What is the big difference you have? That is the beauty of this algorithms here. It uses a different algorithm to store the data. As we discussed, ArrayList uses a algorithm resizability, but it uses a different algorithm to store the data. What is it algorithm this uses? What is it? Linked list. Where is this class? Is yeah. Again list. Different algorithm for storing the data. It is not array. Linked list is not an array here. It is uses internal algorithm is what? Doubly linked list. What is the meaning of doubly linked list here? It uses what it uses here. It uses nodes to store the data. It uses the nodes actually. Right? What is the meaning of node here? So like this, the data will be stored as nodes and nodes. Right? The first node, second node, like this. Nodes and nodes. Right? So where it is, three parts will be there inside these nodes, and here you will have the data, right? And like this, here you will have the data, here you will have the data, here you will have the data. So these two positions are for addresses, storing the address of this node, right? The next data element value will be stored inside this, and here. So like this, doubly linked list, it is going to store the data like this. Each and every node will have, there are two addresses, locations will be there in each and every data element. It will be storing the data of what? Next, as well as previous. Previous arrangement is what? This is linked list arrangement of data. Previous arrangement is like this, arrays kind of arrangement. Can you say what is the difference in between them? Can you say what is the difference between these arrangements? It is simply like what? So you can imagine this is simply like our train where the bogies will be arranged. It is something like that, where each bogie will be attached to it. And this is simply like this. Can you say what is the difference between them? No, no. It is, I can say, continuous memory locations. It is something like continuous memory locations, but it is not continuous. Right? So now try to understand the difference here. So this is what? This is the way of storing the data, adding. So this is the beauty of add method. So the add method is doing this, adding the data like this. Now if you think clearly, there is a big difference is there. The adding the data like this as well as the adding the data like this. What is the difference you have in between them? Now let us take an example. Now take the example like, now in this case I would like to add the data in the middle. This is array list kind of arrangement of data. If I have to add the data in the middle, so what happens here? Or if I delete the data from the middle, what happens here? Yeah, I need to use add method, but my question is, if I add the data in the middle to this kind of arrangement, what happens? My question is, what happens internally? It will increase the size, right? Let's suppose there are 100 objects already there. There are 100 objects already there inside this, and I'm adding one more object in the middle. Let's suppose 0th index, first index, second index, like this I'm having, right? Like this 100 indexes have. Now one object I have added in the middle. What happens here? Second object already occupied with some other data. Now in this place I'm adding one more data here. What happens here? Right? So if I add new data into this position, so what happens here is the already existing data should be moved to the next position. It should, this data which is there inside this, it should be moved to what? Next position. And what happens here? It should be reshuffled entire your data. Let's suppose if I delete the data from this position, all the data should be reshuffled back to each and every element should move one index before. Right? But if I do the same add operation in the middle here, if I do the same add operation in the middle of data, what it should be? What it should be changed here? Right? This is more easy because no need to shuffle the data here. Break this previous link, just add the link, and this will have what? This link. That's it. Yes or no? It is a beauty of our data structures. This is the beauty of our data structures. Right? As I'm talking about performance here, which one is best performed here? This way of arranging the data is more in adding, and this one is more performance in adding. Time taking. Linked list is less time takes. Yes, that is the beauty of these data structures. Performance is better. Here because entire your data should be shuffled. But here there is no kind of shuffling here in the linked list. But it is not that much easy to retrieve the data. It is not easy to retrieve the data whenever your data is stored inside what? Linked list. Because it should start searching from what? First address, second address, third address, like this. It should stay search like this. Array list is better to retrieve the data. It directly jumps to the location and it gets the data. Because it knows where the data is stored, in what index the data is stored. Right? So that's what that is entirely your requirement dependent. Which one I should choose? Both, as I'm talking about why I'm giving this. Both are, that is the first question I have asked. If each and every class in this architecture has the same set of X bits, the same set of things, then why these many classes are required? This is the first question I asked. And this is the beauty of add method. Add method is performing in different way here in this class, and the same add method is doing different operations in this class. And the same add method is doing what? Different operations in this class. Right? So that is the beauty of this. If you want to have your own class, still if you find any kind of algorithm which performs better than these classes, add this class to this hierarchy, you can do that. That is the beauty of this collection framework. Add your own algorithm to this by implementing all those things. Whatever the classes already, whatever the methods already there, just use them, and whatever the methods you want to be better performed, then write them. You can do this. That is what here. So that's entirely that's your requirement dependent. Whether I should go for linked list or whether I should go for what? Array list. It's entirely your requirement dependent. That depends on your requirement. So better according to your requirement, you need to choose that appropriate class. So this class is better to add and delete. This class is better for searching and retrieving. Right? So all classes are given for you. You don't need to put your brain to write your own logics, different scenarios, different algorithm. No, there are few algorithms are given for us. Almost all algorithms which are required for you for developing very common applications, they are there, right? So that is what is the beauty of this framework. So these are all very common operations, right? These are all very common operations you find in each and every application. So this is what here you have a list. Vector, yes. Vector is also one more class you have in this. What is this vector class is going to do for you? How it is different from this? So vector class is said as legacy class. What is the meaning of legacy class here? So actually this collection framework, as I discussed in the previous session, this collection framework is introduced in 1.2 of Java version. It is not there in initial releases. But in the initial releases, this class was there. We want to perform the operations, so this class was there in the initial releases of Java. So this class is said as what? Legacy class. So array list and vector both are same, almost identical. Both are same, performs the same. But coming to the performance wise, array list has better performance than a vector. Array list has better performance than a vector. That is the only difference you have. Just you go through the document, you can find what is the difference. This class is said as synchronized class. Vector objects are synchronized, but array list objects are not synchronized. That is the difference you have. Still you will find some one or two differences. Both are similar classes, but one is old, the other one is new class. Right? So this kind of classes, if you want to perform if you want to perform the operations on group of data, go for these classes instead of writing your own algorithms and all. And absolutely you are free to write your own classes also. Nobody stops you to writing your own classes and performing the operations. But they have provided some ready-made set of classes for us. Getting me? What I'm trying to explain here. So the most important point, as I told you, it is as a programmer point of view, using these classes is very simple. I did not do anything, just change the class name. It has worked for me. But the thing is, we need to understand what this algorithm is going to do for me, what this class is going to do for me, how this class is going to help me. Now my question is, let's suppose I'm going to change again this name to vector. Is this program works for me? Absolutely works for me, this program. No need to touch any single piece. Changing the class name, the internal architecture of the data, internal arrangement of the data will be changes. Yes, this works for you now. I change my collection name as what? Vector. It works. No need to change. But if you have clear picture which class should be used in what scenario, then only it is possible for you to use. Otherwise you cannot use these things. Right? Now I am going to do something here. Now observe this. I am going to take one more class here which I did not explain. Right? This class is from other hierarchy. What is that? Set hierarchy we have previously seen. This class is from sets hierarchy. Is this program works? Absolutely this program works. But this will not work because it is not indexed. This will not work. Remaining works. Yeah. But what is the difference you have? Did you see any difference by changing the class name? No? Yes? Previous data is this entire data is previously, and you see only 4 objects here. Why? What happened when I change the class name? What it is doing for me? That is the beauty of this, right? Now we try to understand what is Z, right? That is not this belongs to that has set class. Whatever I have used, this class is not belongs to what? This hierarchy. This belongs to the some other hierarchy. What is that hierarchy you have? That hierarchy of classes are like this. So that is a different hierarchy you have. That is what? Set hierarchy. Set, what set properties we described? What set properties I described previously? Sets no duplicates, no order, right? No duplicates, no order, one null value. All these are set properties. See, now if I want to write my own logic, let us assume that I have 16 objects inside this, and as a programmer I want to write my own logic for eliminating the duplicates. How much time I need to spend? How much logic I need to write? Let's suppose if it is 16, it's fine. You need to retrieve the data from each and every position, then you need to compare this data with previous data, whether it is already there or not. If it is there, then delete it, then do some kind of XYZ things in your program and do all operations. It is complex. Now I am not going to do anything. See here, there is a beauty of this asset. I did not do anything. That is internally is doing the operations for me. It is eliminated the duplicates. See, no duplicate object you see. Only one time, only AS one time, only one student object, only one account object. How many times I have added them? Multiple times. If you are it is also a collection, same. Not a different thing, collection, group of data, group of objects. But it has different way of collecting the data. It is quite different from what? The list. It is going to collect the data like this. What its specific way of collecting the data? It is going to collect the data for me in the form of what? No duplicates. It will eliminate. So again, who is doing this operation for me? Who is doing this operation for me? Is the beauty of add method again. The add method internally doing the same thing. So how I have added here? How I am doing the adding here? The same method I have used, right? How I am able to use the add method again? Because that add method is from what? That is the reason why I told you to remember that. That add method is from collection, and you have a list here, you have a set here, and this list has add method. In the same way set is also have add method, but the list method, the add method which is there in the list is allowing you to add the duplicates, but the same the add method which is written inside sets is not allowing you to add the duplicates. While adding itself, it is filtering the duplicates things and it is not adding them, but it is allowing. That is the difference you have. So it is very simple to use, right? So what classes you have for this again? So for no duplicates and no ordering, this is entirely different from what? And no indexing, right? Only one null value, because why only one null value means because it is not allowing you to have duplicates like this you have. It's almost entirely opposite to what? The list one, right? Again, in the same way it has, as a programmer, I don't need to write my own programs here. There are already implemented classes for me in the same way, right? Has set, right? This is a one class, and at the bottom you have one more class child for this, linked has set. You have asset, linked asset. You have one most very complex class here, that is tree set. Tree set means it is going to sort the elements. So these are all the classes. You have three classes, three important classes. I can say hash set is the one important actually. So this is also, these are all classes. Now as a programmer, just you can create the objects and you can use them. How to create the objects? As already I told you, each and every class will have what? A no argument constructor. Just you can simply use them. These are the classes you have, and there are some abstract classes in the same way how we have in the list, right? And there are some other interfaces also here. This is where you have one more interface, sorted set. So what is the meaning of sorted set? While collecting the objects itself, we want to arrange them in a sorting order, sort the things. While I'm adding, while I'm going to group the things, I want to grouping at the same time I want to arrange them in a order, particular sorting order. This is going to help you, right? Here you have a class called as abstract set. Same, almost similar architecture we'll find here. I'm not giving entire architecture here. Just this is abstract class. This layer is abstract class. Yeah, yeah. Right. So while adding itself, what it is going to do here, it is going to eliminate the duplicates. So you can see the output of this. So no duplicates you can see because it is eliminating the duplicates. Asset. And you can simply change this class to what? Tree set. Yes. Linked asset means what here? So here I have added 16 objects, but there are each has some 3 duplicates. It is not allowing me to add duplicates. Elimination. It is doing the elimination. I don't bother about eliminating. Just if you whenever you are collecting, as I told you previous example, I am going to eliminate the duplicate election ID cards. Such kind of data if you have, right? Yes, a data you have, just pass all data to what has it. It is going to eliminate the duplicates for you. And in that case, you need to write your own logic. Right, tree set, if I replace this tree set, absolutely this program will not work. Why it will not work, I will explain. Yes, this calling the method is fine. Calling the methods compiles, the program will be compiled, but program will not be executed. Yep, it will not execute for you tree set when I change it to tree set. Right, why? Because tree sets, it is a one special class I can say in this architecture. So what is this tree sets behavior is, while adding the objects, it's same thing. It is not allows you duplicates anything, but it arranges the data in sorting order. Let's suppose I am collecting 4 2 3 1 like this. Now while adding itself, it is going to, Hello, right? Can you hear me? Hello, can you hear me? Hello? Hello?